Welcome back. Well, I'm now going to introduce you to a new, I guess, tool for solving derivatives. And really, between this rule, which is the product rule, and the chain rule, and just knowing a lot of just kind of function derivatives, you'll be ready to tackle almost any derivative problem. So let's start with the chain rule. Let's say that f of x is equal to h of x times g of x, right? This is the product rule. In the chain rule, it was f of x is equal to h of g of x, right? I don't know if you remember that. But in this case, f of x is equal to h of x times g of x. If that's the case, then f prime of x is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. Pretty straightforward. Let's apply it. Let's say that, I don't like this brown color. Let me pick something maybe more pleasant. Maybe mauve. Okay, so let's say that f of x is equal to 5x to the 5th minus x to the 7th times 20x squared plus 3x to the minus 7. So one way we could have done it, we could just multiply this out, and this wouldn't be too bad, and then just take the derivative like any polynomial. But let's use this product rule that I've just shown you. So the product rule just says, let me take the derivative of the first expression, or h of x, if we wanted to map it into this rule. Well, the derivative of that's pretty straightforward. 5 times 5 is 25. 25x to the 4th, right? And then minus 7 x to the 6th, and we're just going to multiply it times this second expression, doing nothing different to it. So maybe I'll just do it in a different color. Times 20x squared plus 3x to the minus 7. And then to that, we will add the derivative of this second function. So the derivative of that second function is, let's see, it's 40x minus 21x to the minus 8th. And that times this first function. I guess I'll switch back to mauve. I think you get the point. 5x to the 5th minus x to the 7th. Right? All we did here is we said, okay, f of x is made of these two expressions, and they're multiplied by each other. If I want to take the derivative of it, I take the derivative of the first one and multiply it by the second one. And then I add that to the derivative of the second one and multiply it by the first one. Let's do some more examples, and I think that'll hit the point home. Clear image. Change the colors, and I'm back in business. Okay, so let me think of a good problem. Actually, well, let me do another one like this, and then I'll actually introduce ones that maybe use the product rule and the chain rule. So let's say that f of x is equal to 10x to the 3rd plus 5x squared, that's an x, minus 7 times 20x to the 8th minus 7. So then we say f prime of x. What's the derivative of this first expression? Right, it's 30x squared plus 10x. And I just multiply it times this expression, right? 20x to the 8th minus 7. And I add that to the derivative of the second expression, which is all in one line, but I ran out of space. 160x to the 7th, right? 8 times 20 is 160. And then the derivative of 7 is 0, so it's just 160x to the 7th times this first expression. 10x to the 3rd plus 5x squared minus 7. There we go. And you could simplify it. You could multiply this out if you wanted, or you could distribute this out if you wanted, and maybe try to condense the terms. But that's really just algebra. So this is using the product rule. So I'm going to do one more example where I'll show you. I'm going to use the product and the chain rule, and I think this will optimally confuse you. sure I have some space. And here I'm going to use a slightly different notation. Instead of saying f of x and then what's f prime of x, I'm going to say y is equal to x squared plus 2x to the fifth times 3x to the minus 3 plus x squared to the minus 7. And I want to find the rate at which y changes relative to x. So I want to find dy over dx. This is just like, if this was f of x, this is just like saying f prime of x. This is just the Leibniz notation. So what do I do in the chain rule? First I want the derivative of this term. And let me use colors to make it not too confusing. So what's the derivative of this term? Well, we're going to use the chain rule first. So we take the derivative of the inside, which is 2x plus 2, and multiply it times kind of the derivative of the larger expression, but we keep x squared plus 2x there. So it's times 5 times something to the fourth, right? And that something is x squared plus 2x. So there, we took the derivative of this first term right here. And then the product rule says we take the derivative of the first term and just multiply it by the second term. So the second term is just 3x to the minus 3 plus x squared, and all of that to the minus 7. So we did that. And then to that, we add plus the derivative of this second term times this first term. So we're going to use the chain rule again. So what's the derivative of this second term? I'll switch back to the light blue. So light blue means the derivative of one of the terms. So we take the derivative of the inside. So the derivative of the inside is, let's see, minus 3 times 3 is minus 9. X, go down 1 to the minus 4 plus 2x. And now we take the derivative of kind of the whole thing times minus 7 times something to the minus 8. And that something is this inside. It's 3x to the minus 3 plus x squared. And then we multiplied this thing, this whole thing, which was the derivative of the second term, times the first term. Times, and I'm just going to keep going, times x squared plus 2x to the fifth. So this was a really, I mean, you might want to simplify it at this point. You could take this minus 7 and multiply it out and all of that. But I think this gives you the idea. And if you had to multiply this out and then do the derivative as just a polynomial, this would take you forever. But using the chain rule, we were actually able to, even though we ended up with a pretty complicated answer, we got the right answer, and now we could actually evaluate the slope of this very complicated function at any point just by substituting the point into this fairly complicated expression. But at least we could do it. And I think you're going to find that the chain and the product rules become even more useful once we start doing derivatives of expressions other than polynomials. Where I'm going to teach you about trigonometric functions and natural log and logarithm and exponential functions. And actually, I'll probably do that in the next presentation. So I will see you soon.